button shader, and hopefully everything works fine. Good. Hello there, Dimanari in the editing room, recording some intro to the latest video. This video is going to include both a plan for the future, what are going to be the next 3 chapters, and after that is going to be the implementation of the first of those 3 chapters. Phase 1, we're going to make a UI, so just some clickable area, struct with 5 fields, test it for hover and click, and then all of those, make a new shader that can support this new structure, shader that takes the thing, yes, and update a quad with color based on the state, add text on top of clickable areas, and just call the function that we discussed before with the clickable areas to put the text in there. We're probably going to need to add a third one, and we might want to add a new type of text rendering that would allow us to scale the text size with floating point values that would let us just double or half the text size. After that is going to be the asset manager, because when we deploy the game, we don't want random files just laying about. We want all of our textures, all of our shaders, all of our language files, everything basically, our font atlas, everything should be pre-compiled. Why should we need to make a lot of stuff that doesn't really support anything when we can just add everything into our basic package, and with that basic package just make the whole game. Basically phase 3 would be mod loader and load a single DLL / dynamic library for Linux with some static name that handles most of the game logic. This way we will be able to issue new updates with just asset and mod updates. The base engine would stay the same, and all of the assets and game mod would be loaded into a dynamically linked library, which is DLL, or I think it's an .a or .s in Linux. It's one of the two. It's either .a or .s or something similar. It functions the same way as a DLL. It's just something that you would have an API to work with, be some load mod data, and then you would have some function handlers, default functions embedded in engine, etc. So that is going to be the start of the actual game when we have this mod loader. Hello there, Dimanai here, back to the game engine project. I cloned the template of part 2 with a few modifications, so we can call it part 2.5. This is the template we're going to use for this chapter, part 3, when we add the UI elements. So what does this code have that didn't exist before? One thing that didn't exist before is this function find in Atlas. This function is a binary search over our sorted glyph database. And for our level, we added a few functions that do basically the same thing. So string update to is what we're going to use for more stuff. String update to all, because it uses a character-based message and not a uint16 message. Now, how are we handling this? Basically what happens is that we have a soft new line location. Whenever we enter a space, we record it for our new soft line break, and this allows us to run through the entire message and basically jump back to the locations that are what we want to do when we break. If we reached the end and we are not a new line or space, which is also another option to just do a new line instead. And we have a soft line break that exists and isn't 0, because whenever we do a soft line break, we reset the last soft line. Then if we have a new soft line break, we return to the last soft line break, we reset the counter to that last soft line break. The X position is going to be reset to the start, and the Y position is going to be incremented by the line width, or the line height rather. Then we're going to continue. If there is no breakable line or soft line break, we are going to do a word wrap and just break the line in the middle of a word. That is for very long words that don't fit into the line, or when our lines are really short. Another thing is that at the end of the function, it returns the count into the end pointer, which we pass here, so that we know how many characters the current buffer actually have. As you can see, that the count is capped to the max string count, and this allows us to do a lot of things. Also, we do not add glyphs and increment it if the glyph size is 0. Basically, if there is no glyph, there is no need to capture a spot. We're still going to increase the position X with the advance. This is also why we can do this and check if we basically ran over the line ending. So then the end count is set to the counts, basically count and reference to count, so that it would be set. Then we init render buffer with all of the count, and when we render it, it would show the two messages. This is some random text that can render on new line screen, and this is another random text that can render on screen. Both of them have different line width. Basically, it starts with x equal 40 and end with x equal 320, and this is 40 and 520, so that the line break is different. This shows us that we can support multiple strings on the screen at the same time. It doesn't really matter. Those strings don't even need to be correlated, only that the end of one string is the start of the next one. So let's add a new type of file. This is going to be a header. Let's call it clickable, struct clickable, because it's going to be a struct. We're going to add our includes position glm ivec2 size int state, and now we're going to have our bool is interact to mouse pause. We're going to make it an inline. Basically what we're gonna do is we're going to add mouse pause minus equal position, just make it a local. And now another one, inline int input stl event e. Let's go to our level and see the type of stuff in here. This is slow but universal. We're going to have other systems for that later that we can make that just use is interact inside each of those. We can even add certain optimizations that makes it so that each element is inside of a container element that only checks one axis each time. So when we check all of those things, they check via axis, and then instead of testing both axes in every clickable item, we're going to test one axis until we find the correct location, and then we are going to test the other axis for the internals. That is basically some optimization for later if we want to make bigger and more complicated input areas, but this is fast enough for pretty much anything anyway, because those events are once per button. We're not going to have that many buttons most of the time, and if we are going to have them, then we're going to make the basic optimizations for stuff like that. So now that we have a clickable, we can also see that it's a struct with size of 20 and alignment of 4 because it has 8, 16, and then 20 bytes. No virtualization table, so it's just the raw data. So now let's go and include clickable hello. So let's go and make some static function, make clickable. It's going to have glm ivec2 pause size message, and we're also going to need to pass those, and we're going to have an str count. Okay, so clickable click position equal pause size state equal 0. Okay, so now let's make another glm ivec2 glm ivec2 and pause is equal to pause plus size. Great. Now string update to old is going to take message string avert str count start.x and pause.x pause y and info, then return click. Hello is a clickable, so make clickable in, let's start it in 480 with a size of 150, message of hello button and string reference to count and text info. Now we're going to do hello input see event, and if 1 plus 2 if it's 3 equal to this quit equal true. I completely forgot to change the startup project, so now stlgl part 3. You can see hello button is here. When we click it, it closes the game. We can't see it yet because we're not rendering our buttons. So let's add a new render buffer 3 button renderer and a new shader button shader, and then attributes 3 button attributes 3. So it's going to be, this is the offset after, if I remember correctly. Yeah, so there is no padding after, and it's just 2 ivex and 1 int. Button size of clickable static draw reference to hello with count 1. Because hello is a clickable and not a clickable array, we are going to pass it by reference instead of by value. Now button shader is not going to care about sprites. It is going to care about screen size. We don't really need to do those to set the shader uniforms because they take the program ID, right? Oh, wait, we probably do. It's a location value. Well, I'm not sure, but I think we should rather do those. It's going to be a shader to vertex, a shader to geometry, and a shader to frag. Yeah, we're going to make completely new everything. Okay, and I'm back. I just added the shader 2s as copies of the original shaders. They're not doing anything differently right now. Okay, we don't need sprites here. We're just going to have sprite in, going to be a state, and that is going to be gl position. Now for input, ivec2 patient 1 2, and this is going to be a size, and this is going to be a state. Shader to geometry texture sprite is going to be just vec2 0, and size sprite is going to just be 1. We're not going to use those. Sin size y, yeah, it is everything working as intended. Now fragment shader, just vec4 instead of this, and we're going to calculate our color. So vec3 color is going to be 1, and we're going to do color comma 1 color.r minus all state. Yeah, that should be enough. And go back to our level. In the header, we're going to have button shader, using those new shaders, and we're going to put a breakpoint in here to see that everything compiled correctly. And there are some error. Undefined variable sprite index in geometry shader. Geometry shader, it should be GS in sprite index. Yeah, that should be enough. Error integer variant state must be flat. Oh, when we do the output, the float, we convert this to float, then geometry float and fragment float in the geometry shader from float to int. Right, float. Yes. And everything should be fine. Continue. Oh, I done goofed. Continue. Great. Now when we render, we're going to be render button shader, and hopefully everything works fine. Good. Now we forgot to do some ordering because the button should be rendered before the text, and as you can see, this works fine. When we click in there, then it shows properly. Another thing is that this should be at the end, so it renders above everything. And when we do update data for our button renderer on reference to hello, does it? No. As you can see, when we actually update it, the color of the button changes based on whatever we do, and when we click, it does the inputs update. Of course, if we right click, then nothing really happens. If we left click, it works. And with this, we actually have everything set up. Clickable area, struct with 5 fields. It tested for hover and click. Render the areas. It updates based on color based on state. Add text on top of the clickable area, which is just calling this. So now that we have a UI element that we can actually stack those, we can make an array of those things, and we can make our main menu using those. And all we need to do is just remember to make clickable before we initialize the string buffer.